Hello and welcome to our presentation from AS1205A. Today, we are taking a closer look at crystalline solids, the hidden order inside solid matter. From sparkling crystals to the materials used in everyday technology, crystalline solids shape the world around us in ways we often don't notice. So, join us as we uncover the structure, beauty, and significance behind these perfectly arranged solids. Before that, let's get to know our group members.
The objective of our study today, by the end of this video, we will be able to define what crystalline solids are, differentiate crystalline solids from amorphous solids, identify the main types of crystalline solids, and explain the basic properties related to crystal structure.
So, what are crystalline solids? Crystalline solids are solid substances where the atoms or molecules of the substances are packed or arranged in a three-dimensional ordered pattern known as the crystalline lattice. This gives the crystalline solid some definite shapes or boundaries where the melting points are anisotropic. Crystalline solids are ubiquitous, which means crystalline solids can be found in nature and everyday materials, include substances such as sodium chloride, sugar, quartz, diamond, and among many others.
Let's start with the definition of crystalline solid. Crystalline solids are solids in which particles are arranged in highly ordered and repeating three-dimensional structure known as a crystal lattice. In this lattice, atoms, ions, or molecules occupy fixed position in a regular pattern, giving crystalline solids distinct physical properties. Common examples include sodium chloride, diamond, and iron. Now, let's move on to the characteristic of crystalline solid. Crystalline solids have several characteristic properties due to their regular lattice arrangement. First, they have a definite shape because the particles are held in fixed position. Second, they possess a sharp melting point as all particles experience the same bonding environment. Third, crystalline solids exhibit anisotropy, meaning their physical properties vary with direction. Finally, they undergo cleavage along specific planes, splitting along well-defined surface. All these properties result from the highly ordered three-dimensional structure of crystalline.
Now, let's move to the other part of discussion, which is types of crystalline solids. Crystalline solid can be classified into four main types based on the particle present and the forces holding them together. The first one is ionic crystals. Ionic crystals are made up of positive and negative ions held together by strong electrostatic forces of attraction. A common example of an ionic crystal is sodium chloride or NaCl. Ionic crystals are usually hard and brittle, and they have a high melting points due to the strong attraction between the oppositely charged ion. And the second one is covalent or network crystals. Covalent or network crystal consists of atoms bonded together by strong covalent bonds throughout the entire structure. Examples including diamond and silicon of dioxide or SiO2-. These crystals are extremely hard and very high melting points because breaking them requires breaking strong covalent bonds. The third one is metallic crystal. Metallic crystals consist of metal cations surrounded by a sea of delocalized electrons. Example including copper and iron. Because of the freely moving electrons, metallic crystals are good conductors of electricity and heat. They are also malleable and ductile. And the fourth one is molecular crystal. Molecular crystals are made up of molecules held together by weak intermolecular forces such as hydrogen bonds or van der Waals forces. Examples including ice and dry ice. These crystals are generally soft and have low melting points because of the forces between the molecules are relatively weak.
For the comparison, particles are arranged in regular and repeating order for the crystalline solids, while the amorphous solids are arranged randomly. The crystalline solids structure are in long-range order and amorphous solids in short-range or no long-range order. Crystalline solids has a sharp and fixed melting point. On the other hand, amorphous solids is softened over range of temperature. The shape for crystalline solids is definite and regular, while amorphous solids having irregular shape. Both crystalline and amorphous solids having same physical properties, which is same in all directions. The difference between them is crystalline solids is an anisotropic, while amorphous solid is an isotropic. Crystalline solids will break along smooth and flat surface, while amorphous solids can break irregularly. Crystalline solids have definite heats of fusion, and amorphous solids have no heat of fusion. Salt, sugar, and diamonds are the example for crystalline solids, and glass, rubber, and plastics are the example for amorphous solids.
For the conclusion, crystalline solids are materials in which atom, ion, or molecule are arranged in a highly ordered and repeating three-dimensional structure. This regular arrangement results in distinct physical properties such as definite geometric shape, sharp melting point, anisotropy, and cleavage along specific planes. Crystalline solids can be classified into ionic covalent, metallic, and molecular crystal, each exhibiting unique bonding and properties. Understanding crystalline solid is essential in inorganic chemistry as it explains the behavior and application of many materials used in daily life and industrial process.
And here is our reference that we use for our presentation. That's all from us. Thank you for joining our discovery.